Welcome back to another video. This is Dr. Tarcia Hubert here, and in this video I am going to be talking about truth tables. We're going to be talking about the introduction to truth tables, and specifically we're going to look at truth tables for negations, conjunctions, and disjunctions. Alrighty. So before we get started, let's lay it out on the table. What is a truth table? So a truth table is a mathematical table that's used in logic that displays every possible truth value of a simple statement and or compound statements. Okay, so we're going to be looking at every possible truth value of a simple or compound statement, and we're going to display it in a table. So the first statement we're going to look at is the first truth table that we're going to look at is the truth table for the negation. So I'm just going to look at one simple statement P. I'm going to call that statement P, and I'm going to look at all the different possible values that P can be. Okay, so P can basically be true or it can be false. So I have a T here to represent true, and I have an F here to represent false. This column, this first column, represents P and the value of P. Now I put two columns because in my second column I'm going to put the negation of P, which is the squiggly line and the P. Okay, now remember that the definition of negation was you take a value that's true and the negation makes it false, or you take a value that's false and the negation of it makes it true. So the negation of P, if P is true, will be false, and the negation of P, if P is false, will be true. So in this table, in this truth table, I've displayed the possible options for P and the negation of P. Okay, so the next truth table we're going to look at is the truth table for the conjunction. So remember, conjunction is when you take two simple statements and you combine them with the word and. So if it's a conjunction, then there's two statements. So I'm going to use P and Q to represent my two statements. Okay, so now I have to list all the possible options that can happen between P and Q. So the first thing is that P and Q can both be true. All right, that's option one. The second option is P can be true and Q could be false. Now the third option is P could be false and Q could be true. So basically I just switched the true and which one was true and which one is false. And then the last case is they both can be false. So these are all the possible combinations of how P and Q can play out, whether they're true or false. And so what we want to do now is look at what happens with P and Q. So remember that upside down V is the conjunction symbol or the symbol for and. Okay, so now think about this. If I said that P represents I am from Waco and Q represent I graduated from Baylor, when is that statement true? That's what we want to consider. Okay, so if P represents I'm from Waco and Q represents I graduated from Baylor, when is the statement I'm from Waco and I graduated from Baylor true? That's what we want to think about. So that would be true when both statements are true. If I'm from Waco and if I graduated from Baylor, then that statement would be true when we combine those together with the and. So with the conjunction, a conjunction is only true when both statements are true. Okay, so that would be in this first case here. If P is Q, if P is Q. If P is true and Q is true, then the P and Q would also be true. All right. Now, the first one is true and the second one is false. Since they're both not true, then the P and Q would be false. The first one is false and the second one is true. Since they're both not true, then the P and Q would be false. And since they're both false, the P and Q would also be false in that last case. So with the conjunction, the only place where it's true is when the first statement and the second statement is true. Okay, so now just thinking about where I actually fit in that table. So I am from Waco, but I did not graduate from Baylor. So my P would be true and my Q would be false. So if I said I'm from Waco and I graduated from Baylor, that statement would be false. Okay, so that's how you use this truth table. You figure out which one of these cases actually happened, but the table gives you every possible case that could happen. All right, now let's look at the truth table for the disjunction. So now we want to look at the truth table for the disjunction. So again, since it's a disjunction is when you take two simple statements and combine them with the word or. So that means I have two simple statements. Again, I'll use P and Q. And then I want to think about all the different possible combinations of how P and Q could be true. And it's going to be just like in the conjunction truth table. They both can be true. The first one can be true and the second one can be false. And then switch those. The first one can be false and the second one can be true. And then they both can be false. So that's all the different possible combinations of how P and Q can both be true or false. So now I want to figure out P or Q. Okay, so now going back to my original example, P is I'm from Waco and Q is I graduated from Baylor. When is the statement I'm from Waco or I graduated from Baylor true? So think about that. That statement would be true if only one of those are true. If at least one is true, or when both are true. Okay, and this goes back to when we talked about the exclusive or in a prior video. Exclusive or means P. It could be P, it could be Q, or it could be both. So if P is true, or if Q is true, or if they're both true, then that truth value for P or Q would also be true. Okay, so what does that mean? Well, here, at least one of them is true. Both of them are true. So P or Q would be true. Here, P is true, Q is false. Well, at least one of them is true. So that statement P or Q would be true for that case. Here, at least one of them is true. So the P or Q for this case would be true. And then here, neither one of them is true. So that would be false. At least one of them has to be true in order for the disjunction to be true. All right. So this is what your truth table for the disjunction would look like. Now, whenever you have a truth table that has two simple statements, then you'll always set it up, this first part, these two columns like this. So you can get in the habit of doing true, true, false, false for P, and then alternating the true, falses for Q. Okay, so that's just a side note. Whenever you do a truth table with only two simple statements, then you will do true, true, false, false for P, and true, false for Q. So that's a good way to set up every truth table with two simple statements. All right, so now we're going to look at some examples of how we can construct different truth tables for different compound statements. Okay, for this first example, we have these two statements. We're going to let P and Q represent these two statements. P is 3 plus 5 equal 8, and Q is 2 times 7 equal 20. And what we want to do, first of all, is just determine the truth value for each of these four statements. So we have four different statements here that involve negations, disjunctions, and conjunctions, and we want to determine if these statements are true or false. So the first thing we need to do is determine whether P and Q are true or false. So 3 plus 5 equal 8. That is a true statement. So P is a true statement. Alrighty. 2 times 7 equal 20. That is not true. That's a false statement because 2 times 7 is 14. So Q is false. Okay. So we want to know whether P and Q is true or false. So that's a conjunction. Remember, conjunctions are true when both statements are true. And so here the P is true and the Q is false. And so true and false is a false statement. So that would be a false statement. Alrighty. Because they both have to be true in order for the conjunction to be true. All right. Here we got P and not Q. So we need to know what is not Q. Well, if Q is false, then not Q would be true. And let's just go ahead and figure out what not P is also since we're here. P is true, so not P would be the opposite of true, which is false, okay? So not P would be false and not Q would be true. Well, in this case, P is true and not Q is also true. So that's true and true. Well, in a conjunction, it is true when both statements are true. So this would be a true statement, all right? So you have to remember the fact that with the conjunction, it's true when both statements are true. And with a disjunction, it's true when either of the statements are true or they're both true. All right. So not P or Q. Well, we found out that not P was false and Q is false. And that's a disjunction. Disjunctions are true when only one of them are true. In this case, neither one is true. So that would be a false statement. All righty. Not P or not Q. Not P is false and not Q is true. So that is a false or a true. So you got a false and a true statement and an or statement. And that would be true when at least one of them is true. And since the not Q is true, then that would be a true statement. Okay. And so you can also look on the truth table for the conjunction and see what that is when the first one is true and the second one is false. What that is when the first one is true and the second one is true, and so forth. And the table will also tell you the answer. But if you just think about it logically, know when they're true, know when they're false, then you can also figure it out that way. So that's how you would determine the truth value of these statements. So now let's construct some truth tables. Okay, so there are 3 steps to constructing the truth table. And the first step is you want to list all of the simple statements first. So look at the statement that they give you to construct the truth table for and see which simple statements are involved in it. You want to list those simple statements first. Then you want to determine the remaining column headings by taking the compound statement that they give you and breaking it down statement by statement. And then the last column should be the final statement that you are trying to achieve. And then step 3 is you want to fill in the truth values under the column headings. Okay. So we want to use those steps with this first example. We want to construct, or example 2, the first example for constructing the truth table. We want to construct the truth table for not P and Q. So I want to look for what simple statements are used in this compound statement and P and Q are used. So my first 2 column headings would be P and Q. All right. Then I want to determine the remaining column headings by breaking this down piece by piece. So parentheses, just like in algebra, parentheses is what you start with. You start with parentheses in logic as well. So I will start with the P and Q. So the P and Q column will come next. And then the last thing I would do is negate the P and Q. So that would be my last column, the negation of P and Q. So I will have 4 columns for this particular truth table. And the number of columns you have will vary depending on how many sets of operations you have in that compound statement. So now you start by filling in the truth value. So remember when there are 2 simple statements, you fill them in by saying true, true, false, false, and true, false, true, false. This is how you will fill in every truth table if there's only 2 simple statements, okay? When you start adding simple statements, then you fill it in differently. So now I want to determine what is P and Q. So remember, that's a conjunction. A conjunction is true when both are true. So that's only in the first case. Only in the first case are they both true. So that would be my column for the conjunction P and Q. And then in this last column, I negate the P and Q. So this is the P and Q. Well, now I'm going to negate that statement. So if I negate that, that's false. If I negate that, that's true. If I negate that, that's true. And if I negate this last one, that's also true. And so this final column is actually the truth table I'm looking for, or the values that I'm looking for, but the whole thing is the truth table. It shows all the possible solutions that can happen with P and Q, and then it shows you the end result when you negate P and Q. All right, let's do another example. For example 3, we want to construct the truth table for not P or not Q. So first thing I want to notice is, what are my simple statements? My simple statements are P and Q. So I will write the P and the Q first. And then I have to determine what my other column headings are. Well, I have a not P in here. So I'm going to add a not P. Notice I don't have parentheses here. So the parentheses will tell me what to do next. But I don't have parentheses. So I need to figure out what is not P. I also have a not Q in here. So I also need to figure out what is not Q. And then once I have both of those, then I can figure out that final statement, not P or not Q. Okay, so this truth table has 5 columns. A little more than the last one. The last one had 4 columns. Again, the number of columns will vary depending on what's given in the problem. Okay. So then we start filling in the truth value. So remember, with 2 simple statements, you do true, true, false, false, and true, false, true, false. That's how you'll set it up every time. That gives you every possible combination of how P and Q could be true and false. Well, not P means you negate the P column. So that's true. So the negation of that would be false. That's true. The negation of that would be false. That's false. The negation would be true. That's false. The negation would be true. So that's the negation of P. You just take all the opposite values of P. Now for the negation of Q, you do the same thing, but this time you take the opposite values of Q. So that would be false, true, false, true. So I've negated P now. So now I want to combine the not P and the not Q with the word or. So remember, or is true when at least one of the statements is true. So I'm looking at these two columns, not P and not Q, and it's going to be true when at least one of the statements is true, where neither one of them are true here. So that would be false. Here, the not Q is true, so it would be true. Here, the not P is true, so it would be true. And here, they are both true, so it would also be true. So this will be the final column for not P or not Q, but the whole thing together makes up the truth table. Alrighty, any questions? If you have any questions, make sure you type them in the chat or make sure you personally send me an email, okay? Hopefully you're following along. We're going to work a few more examples. So let's jump into the next one. All right, in this fourth example, we want to construct the truth table for not P or Q and not Q. So this one is a lot longer, which means we're going to have a bigger truth table. So my simple statements in here are P and Q again. So I know I'm going to start my table off with P and also with Q. All right. Then I'm going to figure out what the other headings for my table are by looking at what I have to do first. So the first thing I have to do is group these two, the not P or Q. Well, before I can do these two, I need to figure out what is not P. So my next column will be not P. Then once I know what not P is, then I could do the truth values for not P or Q. All right. Then once I know what not P or Q is, I would need to combine that with the word and with not Q. So actually I would need to figure out what not Q is. And then once I know what not Q is, then I could do the whole truth table, not P or Q and not Q. Okay. I'm sorry, y'all. My tables are a little lopsided, but hopefully you can still follow along. So this is the problem you have when you try to draw your own lines. Okay. So since there are two statements, you start off the same way. True, true, false, false, and true, false, true, false. Alrighty. And then the next thing we want to do is negate P. So that means we're going to change all the values of P. So true, true, false, false will become false, false, true, true. Now we want to combine the not P and the Q with the word or. So remember, or is true when at least one of them is true. So I'm looking at the not P column and the Q column, and I'm going to make this true when at least one of those statements is true. So in this first one, the Q is true, so that will be true. And this second one, neither one is true, so that will be false. And the third one, they're both true, so that will be true. And then the last one, the second one is true, so that will also be true. All right. Now the next column, I want to negate Q. So here's my Q column. So I would take all the opposite truth values of the Q column. So that would be false. The opposite of false would be true. The opposite of true would be false. And the opposite of false would be true. So that's how you negate the Q column. Okay. So now I want to take, this is the negation symbol, the negation of P or Q and not Q. So I want to take this column and combine them with the and, which is the conjunction. The conjunction is true when they're both true. So I'm looking at these two columns because it's the not P or Q and the not Q. So in this case, they're not both true, so that will be false. In this case, they're not both true, so that would also be false. In this case, they're not both true, so that would also be false. And in this case, they're both true, so that one would be true. So this will be the final values for the not P or Q and the not Q, but this whole thing is the truth table that you need to get to that, okay? All right, let's look at one more example. Okay, for this last example, we want to construct the truth table for the statement, I studied hard and aced the final, or I failed the class. Okay, so notice there are three simple statements in this problem. So the first one I'm going to call P, which is I study hard. I'm going to label that one P. The second one, I'm going to label Q, which is I aced the, oh, I wrote that too high. You can't see it. Let me go down just a little. So P is, can you see P now? Yeah. I studied hard. Q is I aced the final. And R is I failed the course. So there are actually 3 statements in this one. So all of the examples we've done before have only looked at 2 simple statements. So now what we want to figure out is we want to construct a truth table for I study hard and I aced the final. So P and Q, or, and that comma lets me know that I group these 2 first with parentheses, or I failed the course. So this is the statement that we're looking for, P and Q or R. So we're looking for P and Q or R. So let's start constructing our table. And our table is going to be a lot bigger because there is 3 statements. And so you will set it up a little bit differently than you set up the last one with 2 statements. All right. So after I do P, Q, and R, my other headings would be P and Q. So I will need a P and Q heading. And then my last heading would just be the P and Q or R. Because I would just take those 2 and put them together. All right. So now when you have 3 statements, you end up with 8 different possibilities of how those 3 statements can be true or false. And so the way you want to set it up is you're going to do 4 truths in a row for P, and then 4 falses in a row for the next ones. And then for Q, you're going to do 2 truths, 2 falses, and you're going to keep alternating like that. So you're going to alternate every 2. All right, so hopefully I could try to keep these lined up. For R, you're going to alternate every 1. So true, false, true, false, true, false, true, false. I want you to be able to see what they're in line with. This one is off a little bit. Let me move it up just a little bit. So that one is false. Okay. So now I need to do P and Q. So I'm looking at the P and Q column. It's a conjunction. Remember, the conjunction is true when they're both true. So in this first case, they're both true. In this second case, because I'm looking at P and Q, they're both true. They're not both true here, so that will be false. They're not both true here, so that will be false. They're not both true here, so that would be false. They are not both true here, that would also be false. They are not both true here, that would be false. And they are not both true here, that would be false. So that would be my P and Q column. So we have true, true, false, 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 false. And so the rest are false. So the first 2 true, the rest are false. So now I want to do the P and Q column or R. So I'm looking at these 2 columns now, the P and Q and the R, and I'm combining them with the word or. The disjunction is true when at least one of them is true. So it's going to be true when at least one of these are true. And so here they're both true, so it'll be true. Here they are both true, so it will be true. I mean, no, they're not both true. Here one of them is true. As long as one of them is true, it's true. Here one of them is true, so it will be true. Here neither one is true, so it will be false. Here one of them is true, so that will be true. Here neither one is true, so that will be false. One of them is true here, so that will be true, and neither are true here, so that will be false. And so this will be your truth table for the statement, I study hard and I aced the final, or I failed the course. Okay, there's a second part to this problem. So consider the fact, or consider the case that you study hard, you do not ace the final, and you fail the course. And we want to know, under those conditions, will that compound statement, the one that we're looking for, will that be true or false? So you study hard, so in that case P is true. You do not ace the final, so in that case Q is false. and you fail the course. So in that case, R is true. So under those conditions, I'm looking for the case where P is true, Q is false, and R is true. So true, false, true. So true, false, true is this case right here. And under those conditions, the P and Q or R is a true statement. So that would be a true statement under those conditions. Okay. So this is how you construct truth tables with conjunctions, disjunctions, and negations. If you have any questions whatsoever, don't hesitate to send me the question. If this all makes sense to you, then I'll see you in the next video when we talk about truth tables for conditionals and biconditionals. Thank you for tuning in, and I'll see you in the next video.